Bismillahirrahmanirrahim. In this video, I'm going to talk about testing of hypothesis for two independent samples with respect to the means as well as with respect to the variances. So first of all, if you want to test the difference between the two means and both the samples are population and the population standard deviation are given, so then we can apply the z distribution, as well as if the sample size is large enough, then we can apply the z distribution. Both the cases in real scenario it's quite tough, but that's why most of the cases whenever the population standard deviation was unknown, whatever the sample sizes are, we can apply the t distribution, or you can say the t-test. But in order to apply the t-test, so there is a two main condition we need to fulfill before applying the t-test. Number one is both the samples must follow the normal distribution, and the second thing is we need to check is the variances of the two samples are equal or not equal. If there is a equal, then we will, by assuming equal variance, we will apply the two sample independent t-test. If the variances are unequal, or you can say not equal, then we will apply two sample independent t-test with unequal variance, which is also known as Welch approximation. One more thing, when we are talking about we want to compare the two groups, that means you are interested into comparing the performance of the two shifts with respect to the production rate. Is the production rate is equal in shift A as well as in shift B on average. You want to compare the performance of two persons with respect to the marks obtained in different subjects on average. So these are the basically tests for the means perspective. Similarly, when we are saying equal variance or non-equal variance, that means we are talking about the homogeneity as well as the heterogeneity tests. So that means is the both groups has same variance or the equal variance or not. So then if the data is normal, we can apply the F test to check the equality of the variance. But if data was non-normal, then we will apply the Leibniz test. But here in this video, I'm going to talk about the F test only, like how we can apply the F test using R. So in order to do that, to test the two sample independent t-test as well as two sample independent t-test when the variances are unequal, for that I have taken the example of this one, and the example is we have taken the 20 patients data about the hospitals, and we have taken the data of patient satisfaction rating of the two hospitals. So that means here in this case, as I told in previous videos, like always see your question or your problem with respect to X into Y sense. So X would be considered as a factor and Y would be considered as a measurement value. So right now Y is your rating, right? Y is your rating and X is basically the hospital type. Okay, hospitals. So and hospital type we have two types. So right now we want to compare is the mean of the hospital A is equal to the mean of hospital B, or the alternative is the mean of hospital A is not equal to mean of hospital B. So this thing also can be written as H naught mu A minus mu B. So that means the difference between the two hospital rating is 0, and alternative would be A is difference is not equal to 0. This is the two-tail test. Okay, it could be one tail, could be less than, could be greater than form, but right now the scenario is we are interested in the two-tail perspective. So two-tail mean is there any difference between the two hospitals or not? Okay, so right now we are not saying that a particular hospital with respect to the patient rating is better or less. We just want to check is the on average with respect to the patient satisfaction rating, the two hospitals are equal or not equal. So in order to do that, so I'm using R. to apply this test. So first of all, I need to import the data set, and the import data set which I am using is the hospital comparison. So in order to import the data, what I will do, I will go to the environment, import data set from Excel, browse, and then I will go to the directory where I have put the data. That is over here, hospital comparison. Okay, so when you import the data, you will see Excel R will automatically run the commands that it is calling the library of reading the Excel file, okay, as well as loading that library, or you can say the package, then saving the entire data set in a variable called hospital comparison. So whatever the file name, it will save in the name in the same variable. Okay, so whatever the file name would be, so what R will do, make a variable of the same name of the file, and this all the data will be stored in that variable. So as well as we are saying view this data set, so we want to view this data set as well. So if I click import, now we can view the data set as well as this data set we have imported. So the first thing we need to do is, once we import that, now we need to attach this data set because we want to use this data set. So in order to use, so we need to attach this data set. So the first thing, the first condition, as we have seen, in order to apply the t-test to independent sample t-test, we need to check the normality of the data. So first thing what we are doing, this thing we already done for the previous test as well, if you can watch my previous videos. So the first thing is what I am doing, I am partitioning the page in 2 by 2. In 2 by 2 means in 2 rows 2 column, and the first thing we are plotting, that is simple index, as well as on y-axis we have the actual data values. So we have total 40 data points, 20 for hospital rating A and 20 for B, right? And both are independent. And then we are applying the histogram to check the normality. It seems look like a normal, as well as we are applying the normal probability plot, which is QQ plot. Okay. So with the help of QQ plot as well as histogram, we can see that is the data follow the normal distribution, but this is purely a descriptive approach. From the QQ plot, we can see that if the dotted points lying on the straight line, which is a normal probability plot, then we will say data follow the normal distribution. As well as if the histogram is following a symmetrical curve, then we will say data is normally distributed. But remember that we can only hypothesize that this data may follow the normal distribution using these graphs. But for that, as I earlier told you in the previous videos, so we have some sophisticated methods, or you can say sophisticated tests, like Anderson-Darling test to check the normality. We have Kolmogorov, we have Shapiro-Test. Okay, so we can apply this particular test on the variable called, that it was rating, which is a numerical variable. So if I run this test, and I can see the result that the p-value is 0.56. So that is indicating accept H0. So when the p-value is greater than your pre-decided alpha value, okay, so the p-value is greater than or equal to your pre-decided alpha value, and right now the p-value is 0.5637, whereas your alpha is, let's say we are considering 5% alpha. So this is p-value is greater than or equal to the alpha value, so we will say accept H0. Okay, so accept H0 mean, that means data follow the normal distribution, because in any normality test the H0 would be equal to, we will say data follow normal distribution, whereas H1 would be equal to data do not follow do not follow the normal distribution. So because the p-value is greater than, so we will say except h naught, that means data is following the normal distribution. So the first you can say assumption in order to apply the t-test is fulfilled, that is data is following the normal distribution. And the second thing is, we need to test is that we need to check is the variances are equal or not equal. That means we are going to apply the homogeneity test. Okay, so in order to do that, so we can apply the equality of variance tests in such test. So that means we are going to apply the f test because data is following the normal distribution. Okay, so in order to apply the f test, so basically our h naught is sigma 1 square is equal to the sigma 2 square. Okay, and the alternative would be sigma 1 square is not equal to sigma 2 square. So that is basically the homogeneity test. We need to check is the population variances are equal of the both the groups or not. So same test can be written as, so that is sigma 1 square divided by sigma 2 square is equal to 1. Okay, means the ratio of the variances are equal to 1, whereas alternative hypothesis would be equal to the ratio of the variances is not equal to 1. Okay, so in order to apply that test, we will use this the command that is var.test. Basically, this is variance.test. And then the first variable we will use, that is the quantify variable, that is a numerical variable. So which is rating, then tilde sign, and then we will use hospital, which is basically the factor. So if I run this command and I got the result, if I see my p-value, and the p-values are indicating that this is 0.07. So again, this is greater than or equal to your alpha value, which is 5%, right? Because right now the confidence level is 95%. Okay, so that means our alpha is 5% by default. So if the p-value is greater than your alpha value, we'll say except h naught. So that means both the population has equal variance. So that is homogeneity condition is fulfilled. So for our problem or our data set, the normality condition is fulfilled because the p-value is greater than the pre-decided alpha value, which is 5%. And according to the f test, we got the result that the variances are equal. Okay, so that means homogeneity condition is fulfilled as well as normality condition is fulfilled. So now we can apply the two sample independent t-test by assuming that the variances are equal. So in order to do that, we can use the function called t.test. Then our numerical, or you can say the variable, and the quantitative variable, which is rating, tilde sign, and then hospital. And then we will write down var.equal is equal to true. That means assume that the variances are true. So if I run this command, so we are getting the two sample independent t-test results, where the test statistics result, we got the degree of freedom result and the p-value. Okay, so right now how you will read this p-value, this p-value is quite small p-value. So this would be approximately would be equal to 0.00. So we got 6 zeros and then 213 something. So this is the p-value, right? Because we have the -7. So which is less than 5%, that means reject H naught. That is indicating both the reject H naught means both the hospital does not have the same, both the hospital do not have the same uh, uh, patient satisfaction rating. So one of the hospital has higher rating compared to the other, which we can also see that from their mean values. So if you can see that the hospital mean value is 8.3 and hospital B is 59.3. So maybe possible we can make the conclusion over here that with respect to the patient satisfaction rating, hospital A is performing better than compared to the hospital B, right? But suppose if you want to find out the two sample independent t-test by assuming that the variances are unequal in R. So how you can do that? Just because by default it will assume that the variances are not equal. So I will omit this condition. Okay. So if I run this command, so it will automatically apply the Welch approximation. Okay, by assuming that the two sample independent t-test means the heterogeneity condition means the variances are not equal. By the way, for this particular data set, the data was normal, the variances are equal, so that's why we can apply the two sample independent t-test. But if the data was normal and variances are unequal, then we can apply the Welch approximation, and the criteria in R to apply the Welch approximation is this one. Just skip this command. Okay, now I am de-attaching this data set because I don't want to use this data set more. So just I have de-attached it. Right, G? Okay, so the next test we are going to apply, that is called as testing of hypothesis for two paired samples. So this is also known as the pair t-test, means when the two groups are dependent. Like we have taken the sample before something, and then on a same group we again take the data set from the same sample, you can say from the population, that is such as before and after sense. You can also consider like the example of, for example, we are saying we have the 10 machines and we have taken the data set of the production rate of those 10 machines, and then we have done some maintenance program on those 10 machines, and again we have taken the production rate on those 10 machines to check is the maintenance is significantly impacting on the production rate or not. Okay, similarly you can say that if I'm taking the example of pharmaceutical company, suppose we have selected 20 patients and we have given a medicine to test is the effect of that medicine on those 20 patients is there or not. Okay, so for example that medicine is with respect to the headache medicine type. We have selected the 20 patients and those have the headache. So the seriousness of the headache, and then we have given the medicine to those patients. So before the seriousness of the headache and after giving the medicine, the seriousness of the headache, in order to understand the effectiveness of that particular medicine. So whenever you have the pair form data, before and after sense data, then we can apply the two sample pair t-test, right? Like for example, in this example where I am going to apply the pair t-test, that is basically a psychologist want to determine whether a particular running program has effect on the heart rate. Okay, effect on resting the heart rate. So they want to check the effect of the running program. So they have taken the resting heart rate of each person's before running that program, as well as they have conducted a running program, and then from the same population they have taken the resting heart rate of the person's data. And now they want to check is that running program is effective or not effective. So in order to apply this the testing of hypothesis of mean for pair t-test, so the only assumption is that the data must follow the normal distribution. Okay, so in order to do that, first of all, I need to import the data set of that is resting heart rate, which I can go import. I have it put in the Excel format. Okay, I can go there. The data is resting heart rate. Okay, import this data set. So this is the data set before and after. the resting heart rate, and this is the difference variable. Okay, and then we can attach this data set. So right now what I am doing, in order to apply the two sample pair t-test, I'm using only the simple t-test. And how I am applying that, I have already, as you have seen that we can apply this two sample independent t-test on a difference data. How I have computed that difference, that is basically, you can say, we have the before the running program uh, resting heart rate data, and after running program, and then we have computed the difference. That is basically, if this is x, this is y variable, so we can compute x minus y. So instead of applying this data set, we can use this data set in order to test whether the running program is effective or not effective. How can I do that? So I can use h naught would be equal to mu d, that is the difference between before and after is 0, whereas alternative hypothesis, the difference is not equal to 0. So that means the running program has no effect, that is the h naught, whereas we are saying in alternative hypothesis that the running program has effect. So that means in a resting heart rate, there will be effect if we got to able to accept the h1. Okay, so in order to apply that, we have already attached the data set, and then now I'm going to apply on the difference data set the two sample independent one sample independent one sample t-test. So the one sample t-test p-value is indicating that because we have applied this test on the variable differences, that is before the difference between before and after. So the p-value is less than 5%. Okay, that is indicating we should reject h naught. That means the running program is affecting the resting heart rate. Okay, so that is indicating that after the running program, the resting heart rate is improving. Okay, so that is basically the p-value is indicating that the h naught should be rejected, h1 should be accepted, which means again that this the pair t-test is indicating that the the running program is better for the resting heart rate. Thank you so much. See you in the next video.